On page 3, we're going to talk about natural logarithms. So when you go to your calculator and you see that LN button, okay, that's talking about the natural logarithm, okay? So when you see a natural logarithm written down, it's just like the common logarithm in that you will not be given a subscript of what the base is, okay? You have to know what the base is, okay? So the base for a natural logarithm is base e, okay? So remember, e is that crazy decimal that's about 2.71, okay? So natural logarithms are base e logarithms, okay? Even though the base is funky, it's still going to work the same way. If you look in the box, if you see the statement natural log of x is equal to y, that's equivalent to the following. If you see ln, you know the base is e, so you can write it in and then do the arrow thing. So e to the y power is going to give you x. Okay, so natural log of x is equal to y is equivalent to e to the y power gives you x. Okay, another very important thing, the functions f of x is equal to e to the x and g of x is equal to the natural log of x. They are inverse functions. Okay. All right, so we are going to jump to the properties of natural logarithms. These are the same properties that we've seen with the other bases. We're just going to rewrite them in terms of the natural logarithm, okay? So what's the natural log of 1? Okay, well, this time you can actually pop it into the calculator. The natural log of 1 is 0, okay? Why is that? Well, if you looked at this, okay, we're looking at the natural log of 1, okay, what does that equal? This is saying if we take our base, which is e, what do we need to raise e to get 1, okay? And the answer is 0 because anything to the 0 power is 1, okay? All right, moving on to the second property. What's the natural log of e? Okay, again, you can pop this into the calculator. The natural log of, if you look at, on my calculator, it's on the division key. If you look above it, you see the E button, or the way to pull up E, just the E decimal expansion. So if I do second division, I can pull up the number E. The natural log of E is 1, okay? And again, why is that? Well, because if I take my base E and raise it to the first power, I'm going to get e, okay? So the natural log of e is 1. All right, moving on to the third property. What's the natural log of e to the x, okay? Same thing, okay? If I take my base, which is e, okay? E to what power is going to give me the quantity e to the x? Well, the only way those two things can be equal is if this exponent is x, okay? So this is going to be x. The natural log of e to the x is x, okay? Natural log and e, when they are side by side, they cancel out, okay? So as an example, if you saw the natural log of e to the 10th, okay? This is going to be, you're going to say, hey, ln and e are side by side, they cancel. The answer is going to be 10. Okay, you could see that on a calculator. Okay, what's the natural log of e to the 10th? Okay, boom, it's going to give you 10. All right, last property. Okay, what's e raised to the ln of x power? Okay, again, this version is a little more difficult to visualize with the arrows, but as soon as you see that e and ln are side by side, you know they're going to cancel and leave you with x. Okay, so as an example of this property, if I asked you to calculate e raised to the natural log of 2.1, okay, the e and the ln would cancel out, and the answer is just going to be 2.1, okay? All right, so what we're going to do in example 3, okay, there may come a time where you have to punch some of this stuff into a calculator, especially if you're doing like a word problem or something. So, oh, actually, the calculator thing is in example 4. I was jumping ahead. Okay, so wait, let's go back. Example 3, we're not going to use a calculator here. I mean, you can, but we're going to try to do this without a calculator, okay, based on what we just talked about. And then when we jump to example 4, the numbers will be a little more difficult, and so we will definitely have to use a calculator there, okay? So let's look at example 3. It says evaluate each expression. Okay, so evaluate, you've got kind of a funky looking expression here, and we just want to kind of simplify or get a number out of this, okay? All right, in part A, we have the natural log of 1 divided by 3. Okay, well, if we scroll up, we know that the natural log of 1 is 0. So the numerator here is 0. The denominator is still 3. 0 divided by 3 is just going to be 0. Okay, so that is your answer here. Okay, this whole thing, natural log of 1 divided by 3, simplified to be 0. Okay, moving on. In part B, we're trying to calculate 13 times the natural log of e. Sometimes you just have to kind of read it out to yourself. This is 13 times the natural log of e. Okay, I'm going to leave the 13 out front. Okay, the natural log of e by the second property is 1. Okay, so 13 times 1 is going to be 13. That's the answer. Okay, see, we didn't need a calculator for this. All right, moving on to part C. What is the natural log of 1 over e to the third power? Okay, this one is definitely a little more tricky than the others were. Okay, remember, you've got an ln and you've got an e, and they cancel out if they are side by side. Okay, that's not exactly what we have here. We've got this fraction. So what we can do is rewrite this quantity in parentheses so that it is not a fraction. Okay, so we're going to say this is the natural log of, we're going to get rid of the fraction here. Okay, we can move the e cubed up to the top, but we have to change the sign of the exponent. Okay, so the things in yellow are equivalent. 1 over e cubed is the same thing as e to the negative 3, okay? And now the ln and the e are side by side, and so they will cancel, and the answer is going to be negative 3, okay? Again, if you're unsure, you could pop each of these into a calculator to get the answer, okay? But it is very, very helpful to know these. So now we will go to example 4 and try popping some of these harder ones into a calculator, okay? When you look at these, just eyeball them. The numbers are definitely more difficult. So here we're just going to be asked to, punch these into the calculator to get an answer. Like I said, you may have to work with quantities like this in a word problem, and you might have to get an answer out to solve the word problem, so you might need a decimal approximation. So we're just going to practice that here, okay? So the directions say, in example 4, use a calculator to evaluate each expression. Round your answer to 3 decimal places, okay? So I mean 3 decimal places, 3 places after the decimal point. Okay, so let's put it like that so it's clear. All right, okay, so the first thing we're going to do in part A, okay, we're going to pop the natural log of 10/3, okay, that's the numerator. We're going to divide that quantity by 0.04, okay? 10/3 is what you're taking the logarithm of, okay? So be mindful of that. The 0.04 is not, you're not taking the natural log of that in any way, shape, or form. All right, to do this, I'm going to pull up the calculator, okay? I'm going to type it in pretty much like I see it, okay? So I see natural log of 10/3. Then I need to close the parentheses, okay? Because that's what I'm taking the natural log of, okay? If you're not sure, go ahead and hit enter. That's the numerator. Then hit the division key and divide the result by 0.04. Okay, so that's going to be your decimal expansion. We're going to round this to 3 places after the decimal point. So this is going to be approximately 30.099. Okay, so I'll write that down. This is approximately 30.099. Okay, you could have put it in all at once. Just do natural log of 10/3. Okay, close parentheses, that's imperative, and then divide by the 0.04. Okay, there you go. Okay, it's up to you. All right, moving on to the next one. Okay, we've got it's a little bit more complicated. You've got 2 natural log of 5 plus the log of 50. All of that is divided by the log of 4 minus the natural log of 2. Okay, so you've got to be mindful here. Some of these are natural logs, some of these are common logarithms. So you've got to pay attention and use the correct button here. Okay, let me see if I can squeeze this in so we can see it. Okay, all right, so let's look at this one. So I am going to try to punch it in all at once, okay? But what I'm going to do, I'm going to make sure to put the entire numerator in parentheses and the entire denominator in parentheses. So hopefully you can see, it's kind of tiny here, but I've opened my parentheses and I'm going to put 2 natural log of 5, close parentheses, because you're done with the logarithm. Now we're going to add, and I'm going to have to use log for base 10, okay? And I'm taking the log of 50, close the parentheses, and then I'm going to close the parentheses on the numerator. Okay, so that's what the numerator looks like. Now I'm going to divide. I've got to put the entire denominator in parentheses or it's not going to come out correctly. Open your parentheses, put log, so hit the log button, log of 4, close the parentheses. You have to close the parentheses because you're only taking the log of 4. Then subtract natural log of 2, close the parentheses on the logarithm because you're done with the logarithm, close the parentheses on the denominator. Okay, so let me make this bigger. Okay, so hopefully you can see what I did here. Okay, so I'm going to try to scroll through what I entered so you can see it again. I don't know if it's going to let me do that. All right, here we go. So you can see what I typed in, okay? There are definitely, you've got to be really, really careful with the parentheses here, okay? It's not letting me scroll, unfortunately, so hopefully you were watching the part of the video where I actually typed it in, okay? So let's go ahead and hit enter on this, okay? And then that's going to be the decimal expansion. We're going to round it to 2 places after the decimal point, or actually I think it was 3. So this is going to be negative 53.991, okay? So let me go ahead and write that down. This is going to be negative 53.991. Okay, that's what you should get as your approximation if you punch this in. Okay, that is it for our introduction to natural logarithms. Okay, we're going to move on now and start talking about how you graph basic logarithmic functions by hand.